First example, let's quickly go through these. Questions we kill. Like we don't even wait. Let's say, find the integral of x sine 2x dx. So what are you going to do? You look at this and you say, oh my gosh, these are two functions that are multiplying each other, okay? Two different functions. X is a polynomial, sine 2x is a trig function, and they are multiplying each other, and they've asked us to integrate. Of course, this is by parts, okay? Remember, in differentiation, this would be product rule. In integration, this would be by parts. So, by parts, yes, I'm going to write the word lipet, okay? And see who comes first. So here I have P for polynomial and T for trig. I can see that P comes first. So that means this is going to be my U, okay? And then that means this other guy is going to be my dv dx, okay? So that means it's going to be my U, it's going to be my dv dx. So when you are just going to write for integral of x sine 2x with respect to x, I'm going to say let u equal to x, okay? We don't say x equal to u. It's nicer to say u equal to x, which means that now du dx, okay? And you put a v, you put a comma, and now say that, you say let u be equal to x, and you can put your comma and now say dv dx be equal to this other thing, okay? Let dv dx be sine 2x, right? So now what happens? We'll say, okay, I need du dx, because you need u, du dx, dv dx, and v. So now, how do I integrate? How do I differentiate this? I have u, I differentiate it to get du dx. Derivative of x is 1. Okay, the derivative of x is 1. Now I have dv dx. Now I want v. What is v? V is equal to the integral, okay? So you can say v is the integral of this thing, right? Because I have dv dx. So the integral of dv dx is the integral of this. But I have to integrate like both sides with respect to x. So I can say v is equal to, if I integrate both sides with respect to x, here I'll get v, right? You can do it maybe in 2 steps if you want. Integral of dv dx with respect to x is going to be the integral of sine 2x with respect to x, okay? Then what is the integral of dv dx with respect to x? It's v. It is going to be, what is the integral of sine 2x? There we go. We are back at it. How do I do the integral of sine 2x? Okay, now remember we say that in differentiation, you can remember, or if you want, you can put your common derivatives table. The common derivatives table is very good when you are doing integrals of trig. Integrals of trig, go back to common derivatives table. It will always work. So it's like if you have y and dy dx, right? We remember that when I differentiated sine x, I got cos x, okay? And when I differentiate cos x, I'll get negative sine x. These are the two I need right now. So now I'm integrating sine. So I look for sine on the right hand side. It's here. Integrating is going back, okay? If I integrate sine, it goes back. So here sine goes back to cos, but negative sine goes to positive cos. So that means now positive sine goes to negative cos. So it'll be negative cos to x. But then you must multiply by the derivative of the inside, because this is not sine x. This is a composite function. This is sine 2x, something which is not x. So you start with the outside, then you go into the inside. So if we start with the outside, we start with the sine 2x. It is going to give us negative cos 2x. Then now we work with the inside, which is 2x. We multiply by that, the derivative of 2, which is, we are integrating. So we divide by the derivative of 2x, which is going to be 2, okay? So you say times 1 over 2. It's like dividing by that. So it's like times 1 over 2. This is dividing by 2. And what is 2? It is the derivative of the inside, okay? Now, this is going to be equal to negative half cos 2x. Okay, this is going to be negative half cos 2x. So now I have my v and I have my du dx. So now I can come and then write to say the integral of u dv dx. Now, this is where you have to remember the formula. Integral of u dv dx is going to be equal to uv minus the integral of v du dx. Oh, remember to say with respect to x. My gosh. U dv dx. We are integrating with respect to x. This is going to be uv minus the integral of v du dx with respect to x. So now what am I going to do? Well, let's put the things, because we already put one as u and the other as dv dx. U was this, then the other was dv dx. Remember, we use lipet to choose. We don't use the order in which they are written. Please. So now you can put that this, of course, this is now x sine 2x, okay, with respect to x. This is the u dv dx, right? This is going to be, what is my u? u is x, okay? So it's going to be x multiplying my v. Where's my v? Here's v, negative half cos 2x. So multiplying negative half cos 2x, right? Like this. Then you say minus the integral of, what is v? Where's v? Here's v again, negative half cos 2x. And this is multiplying du dx, which is 1. And we are integrating it with respect to x, like this. What am I going to get? This is going to be equal to negative half x, okay? Because negative half times x is negative half x, then cos 2x minus, what happens here? What happens now when we are integrating this? 1 times this half just remains as half. So it is minus, you can put, the negative half can come outside, negative half can come outside, integral of cos 2x times 1 is just cos 2x with respect to x, like this. So what am I going to get? This is going to be half, negative half x cos 2x, then minus becomes plus half integral of cos 2x with respect to x. And here we have said that this is the integral of x sine 2x with respect to x, okay? Integral of x sine 2x with respect to x. Now, what am I going to do here? Well, the next step is just have to find this part, okay? And it'll be done. I mean, we just have to find this second part. So let's say, what is it going to be? It's negative half x cos 2x plus, now what happens? There's half. We multiply this, the integral of cos 2x. How do we integrate cos 2x? This is very important. First, we integrate the cos, okay? Remember, this is a composite function, yeah. So I know that I'm going to divide the derivative of the inside. But first, I should be able to integrate cos. How do you integrate cos? So we can do the memory if you want, that when you differentiate, we know, okay, let's just put the common derivatives table to be safe, okay? Y and dy dx. This is u. Y and dy dx, okay? And here we have sine x, and we know it differentiates to give cos x. Then we know that cos x differentiates to give negative sine x. So now we want to integrate. So we are starting at the right and going back. What are we integrating cos? So we started cos. If I integrate, it goes back to sine. So positive cos goes to positive sine. In other words, for cos, the signs don't change. So that is for integrating. For integrating, when you're integrating cos, the signs don't change, okay? It's the same. So it's the same as like when we did for different. We say that when you integrate cos, the signs don't change. And for sine, when you integrate sine, the signs change. But when you differentiate sine, the signs don't change. But when you differentiate cos, the signs change. So cos changes in differentiation, sine doesn't change. And sine changes in integration, where cos itself will not change. So in here, cos will not change because this is integration. So it's just going to give me sine 2x. Okay, you integrate cos to x, you get sine 2x. No sign change. But then you should multiply by 1 over, which is like dividing the derivative of the inside. So the derivative of 2x is just 2. So like this is going to be like that. And then, of course, we'll put a constant of integration c outside now. Now we can simplify. So this is going to be negative half x cos 2x, then plus half. Okay, there's another half multiplying in here, so it's going to be this half times that half. When you multiply two fractions, the top multiplies. 1 times 1, 1 over. The bottom multiplies. 2 times 2, 4. So it's going to be plus 1 over 4 sine 2x, then plus your constant of integration c. This is the whole thing. We are done. This is your solution. Okay, you can put now to say the integral of x sine 2x with respect to x gives us this. We are done. Move on to the next question. Bye for now.